Hello and Jai Hind to everyone. In this video, I am discussing about the balancing conditions of Wheatstone network. This is the Wheatstone network. It has 4 arms of resistance PQRS. Let us suppose it has 2 junctions here, AC and 2 junctions above. Okay. So in between B and D, a galvanometer is connected of resistance G. So as from the battery, the current I is passing through the circuit. This current when reaches at A, here what will happen is current will divide. So the current will divide. When the current is divided, sum of current from I is passing through B, this R, that is I1, and sum of the current, that is I2, will pass through this R, that is AD. So when the current is passing through AB, that is I1, again there will be a junction. Now again current will divide. Some amount of current will pass here. As the current is passing through the galvanometer, we can name it like current through the galvanometer IG. And then IG from I1 is passing here. Then how much current will be remaining here? I1 minus IG, because IG is subtracted from I1. Then the current will be here I1 minus IG. The simple example, if it is 5 ampere, if 2 ampere is going here, means 5 minus 2 will be 3 here. That will be 3 here. That will be nothing but 5 minus 2. As 2 is passing here, it was totally 5. 5 minus 2, that is 3 is passing through here. 3 ampere is passing. That is nothing but I1 minus IG. I1 minus IG current is passing here. Okay. Now this I2 current is passing here, and this I1 is also in the same direction. Both combinedly will pass here. That is nothing but IG plus I2. This current combinedly passes through here, and this current and this current again totally it will be again I, and again it will pass. This is the simple construction of Wheatstone's network. Now we have to derive the balancing condition. When will be this Wheatstone network is balanced? That we have to find. So for this we have two Kirchhoff's laws. One is Kirchhoff's junction rule or node rule, or the second rule is Kirchhoff's voltage rule. What Kirchhoff's voltage rule says, the sum of IR product in a closed loop is equal to 0. Okay. So here how many loop we have? Loop A, B, D, A. Loop is nothing but starting and ending point should be the same. So A, B, D, A is first loop. The second loop is B, C, D, B. So for each loop we have to apply KVL. The first one is apply KVL to loop A, B, D, A. A, B, D, A. So the sum of IR product. So as the direction of current is in the direction of the loop, then we can say the IR product is positive. Our direction is like this we are going, and current is also in the same direction, so we can say that it is positive. If our direction is here and the current is coming in opposite direction, so it considered as negative. So as we are going like this, so I1 into P, that is positive, I1 P plus, when we see here IG is also in the direction of the loop, as the loop is from A, B, D, A. So loop direction is like this. Current is also here positive because current is in the same direction. IG, G. Then again our loop is going in this direction to complete the loop. So the direction of the current of I2 is opposite to the direction of the loop. So we can say it as negative. Minus I2 R is equal to 0. This is equation 1. But to balance the Wheatstone network, the current through the galvanometer should be 0. So this means to balance Wheatstone's network, Ig should be 0. Current through galvanometer, current through galvanometer should be 0. So the equation 1 will become, what this equation will become? It will be I1P plus Ig 0, 0, 0. This will be what? Minus I2, directly I am writing minus I2 R is equal to 0. So I can even write I1P is equal to I2 R. This is equation 2. So next we will apply KVL again, that is Kirchhoff's voltage rule for the loop second. This is the loop second. So let us suppose the loop is starting from BC D. So the loop is moving like this, BC D B. Apply KVL to loop BC D B. BC D B. So first we are moving from B to C. The sum of I1 minus Ig, I1 minus Ig into Q. Next we are moving according to the loop, but current is in opposite direction. So it should be minus Ig plus I2 is equal to, again one more current is there. This, our loop is going in this direction, again it is minus. As loop is like this, current is coming in the opposite direction. So minus Ig G is equal to 0. As Ig is equal to 0, as we know, to balance the Wheatstone network, Ig is equal to 0. So the equation will become I1Q minus this Ig is 0, I2, and we forgot this S, minus I2 S, then this will be 0, is equal to 0. I1Q is equal to I2 S. This is equation number 3. We just need to divide equation 1 by 2, as I1 same, I2 same, so that we can cancel. I1P is equal to I2R divided by this I1Q, that is equation 2 is this. No. This equation 2 by equation 3. This is the equation 2. The one is I1P. Equation 3 will be I1Q. The similarly I2R divided by I2S. This I2, this I1 gets cancelled. We get the equation P by Q is equal to R by S. This is the balancing condition of Wheatstone's network.